Hi, Erica. I see you've got a little bit of a unit circle review necessity here. This is the arc sine of negative root 3 over 2. And remember, this means usually you think of trig functions like this, but the arc sine is the inverse, meaning we just switch the x for the y, and we solve for the y. So to solve for the y, you do some mysterious function which would be the opposite of sine, and we see the reason why you do that is to cancel out the signs so that you could just have y, and that is the meaning of arc sine. It is the inverse of the sine. Now, what does that mean? That means that this here is going to be an angle. Of course you know that, but which angle? Now, sine refers to the y-coordinate on the unit circle, of course. So here we have a y-coordinate that is negative root 3 over 2. That negative root 3 over 2 refers to the distance from the origin to this point, from the x-axis to this point, or anywhere at the same height as this point from the x-axis to this point. That is the distance, root 3 over 2. So in the negative direction, negative root 3 over 2 would be the distance from the distance from here to, from here straight down to here. Now that is the y-coordinate because that is the sine. Now the sine inverse is going to get you the angle. So the angle from here to here to get you right here. Why do I insist on pointing here? Why do I not point here? I do that because the inverse sine has a particular range. That range is here only. You're only allowed to live here if you are the inverse sine. You're not allowed to live here. And the reason for that is not natural at all. The reason for that is purely by convention. Mathematicians have just agreed with each other that the inverse sine is going to live here. Why would they do that? They do that so that when they refer to an inverse sine, they always know what the other person is talking about. For example, if you say the inverse sine of negative root 3 over 2, it could be this angle, or it could be from 0 to this angle, or it could be from here, from 0 to all the way this way, this angle, or it could be this way to this angle, or it could be around 5 times and then land here, around, or it could be starting here around 98 times and then land here. So there's an infinite number of angles whereby you could get to sine equals negative root 3 over 2. So we'll just narrow them down just by agreeing with everybody. Hey everybody, let's get together and agree that when we say inverse sine, we're talking about only this side. Similarly, when we talk about inverse cosine, they're only talking about this side, the top half. Okay? So inverse sine has a range. Inverse sine of of anything is going to equal an angle somewhere between negative pi over 2 and pi over 2. By the way, you should have a color copy of this unit circle or something like this pasted on the walls of your bathroom, your car window, your bedroom. It is useful to have this very nicely imbued on your brain, preferably permanently. Now, why is it not then 5 pi over 3? Because obviously this angle is 5 pi over 3. No, it isn't 5 pi over 3 if we're talking about inverse sine, because 5 pi over 3 would be the angle all the way around this way. But remember, the range for inverse sine is agreed upon to be somewhere between negative pi over 2, not 3 pi over 2, but negative pi over 2 to pi over 2. Well, this is 0, and I go to negative pi over 2 this way, and pi over 2 this way. So I need to get the equivalent of 5 pi over 3 in the negative direction. So 5 pi over 3 is really just 1 2/3 pi. So that's 1 pi and then 2/3 pi. Well, that's the same. I mean, if this was 2/3, then this must be 1/3. So the semicircle here, of course, is pi, right? So if this is 2/3 pi, that means this is 1/3 pi. So the angle here within the range of the inverse sine is going to be negative pi over 3. That makes sense? From here to here, that's 1/3 of pi. Pi being the semicircle. Okay. So that's negative pi over 3. So that is why this is negative pi over 3. Okay? Questions about that? Send me email. I can explain this in different ways. I can explain this using the graph of the inverse sine if you prefer. Some people like that better, but just let me know if that is necessary. Okay? So, next question. Next question is sine inverse of sine 9 pi over 8. Now, by now, you may already know the answer to this question. So, if you look for the sine inverse of the sine of 9 pi over 8, right? The meaning of sine inverse, of course, is to cancel the sine. So I cancel the sine. So the answer is 9 pi over 8. However, the function on the outside here, the main function here is the sine inverse. That means the last thing you do in this composition of functions is sine. You do sine first, and then you do sine inverse. However, sine inverse has a particular range. That range is from negative pi over 2 all the way to pi over 2. This is 1 1/8 pi. 1 1/8 pi is way more than 1/2 pi. So this is not allowed. I need to find this on the unit circle. And pi over 8 is not one of the memorized angles in the unit circle. However, the unit circle is still useful. Where's my unit circle? Where is it? Right here. Unit circle. Does this work? Yes. It's still useful to find corresponding angles. So here I have pi, so it's 1 pi, and remember I want 1 1/8 pi, so 1 1/8 pi must be like somewhere right here. You see that? Somewhere right here. Now, what is the sine inverse going to be for this? First of all, what is the sine of this, right? The sine of 1 1/8 pi is the y coordinate. So from the x-axis all the way down to this point. The x-axis all the way down to this point. That would be the sine. That distance would be the sine of 1 1/8 pi. Now, I need to get that equivalent distance shown on this unit circle someplace within the range of sine inverse. Sine inverse, remember, lives over here. So that equivalent distance will be right here. Now, what is the angle that is expressed by this point right here on the unit circle? This point, which I obtain by traveling downward from the x-axis until I hit that point, making sure that the distance I've traveled is exactly the same as the sine of 1 1/8 pi. So when I hit the unit circle, what is the angle that is within the sine inverse range that this point can be described by? Well, it can't be described by an angle all the way around there because that is outside of the range of the sine inverse. So it can be described by an angle that just goes down this way in the negative direction. Now, if this over here, if this was 1 1/8 pi, well, then this must be just negative 1/8 pi because the distance from the angular distance, the angle from here to here must be 1/8. If this was 1 1/8, therefore the distance from here to here must also be 1/8. The angular distance from here to here must also be 1/8. So that means this angle is called negative 1/8 because it's going in the negative direction. Okay, so that means it isn't 9 pi over 8 because we're using the sine inverse. So that means the answer must be negative pi over 8. Okay? This is all because of human rules, right? You just have to be one of the cool kid mathematicians and just play along with these human rules. Let's have a look at the next thing on the list. Looks like you hate half-angle formulas for tan. Well, join the crowd. I know anybody who likes half-angle formulas for tan, but it's a necessary evil, so let's go. Half-angle formulas for tan. So, whoops. Right, so I've got that tan of 9 pi over 8. Now, how can I use the half-angle formula here? Of course, I know that 9 pi over 4 times 1/2 equals 9 pi over 8. So it must be half of 9 pi over 4. Right. Now, half-angle formulas are usually expressed like this, alpha over 2. So if I have half of 9 pi over 4, then what is alpha? Well, that's going to be 9 pi over 4 times 1/2. Right? You can just multiply 1/2 multiplied by 1/2 is the same as divided by 2, of course. So alpha then equals 9 pi over 4. But what is 9 pi over 4? I mean, that is like more than 2 pi because if I want the number 2 pi, that equals 8 pi over 4. 9 pi over 4 is like twice around, one full revolution around the unit circle, and then another fourth, right? It is 2 1/4 pi. So why am I harping on this? I'm harping on this because where's my unit circle? Because it makes the problem so much easier. So if you go 9 pi over 4, that means you go 8 pi. I mean, you go 2 pi, which is 8 pi over 4, right? This is pi. This is 2 pi. Oh, I'm back where I started. That was 8 pi over 4. In other words, 2 pi. Now I still have 1 pi over 4 left to go in order to achieve that angle of 9 pi over 4. So where is pi over 4? Oh, it's right there. Did you see that, Erica? You go 2 pi and then 1/4 pi. So it's pi over 4. So the angle 9 pi over 4 is identical to the angle pi over 4 when we're dealing with the unit circle. It's the same angle. We just traveled a longer distance to get there, but the unit circle doesn't care. Okay, why is that important? That's important because that just makes this problem so much easier. Because 9 pi over 4 is the same angle as pi over 4 as far as we're concerned. So what does that mean? That means that we're dealing with the tan of pi over 4 over 2. That means we can use a half-angle formula full of pi over 4 sines and cosines. So, that's going to make our lives so much easier. Here, let me show you. Actually, let me go get a nice half-angle formula first. Where can I find a nice half-angle formula? Tan, yes, a tan half-angle formula. No, that's not nice. That's kind of nice. I guess I can use that. Is there a better half-angle formula here? Okay, I have a positive angle here, so I'll use positive sine over 1 plus cosine. I'll use that one. How about that? Sine over 1 plus cosine. So I've got the tan of pi over 4. The half-angle formula equals the sine of that alpha, which is this, over 1 plus the cosine of that alpha, which is this again. Right? And what is sine pi over 4? Oh yeah, you're right. That's what it is. And what is cos pi over 4? Oh yeah, you're right. That is what it is. So let's clean this up just a little bit, shall we? How should I clean this up? Well, let me make this a little more manageable here first. Okay. Now I don't have this double decker anymore. Okay, good. I can combine these, of course. Maybe, but that might not be what I use with maybe. Let's try. In math, of course, Erica, you just try things. No use just dithering about wondering if this action or that action would be suitable. You just have to try things. That's why getting a lot of practice problems is very important in math, just like in chemistry. But anyways, I digress. If I want to make this into a single denominator, in this denominator, I would have to multiply this guy by 2 over 2, which is just like multiplying by 1, so it's legal. So that would be 2 plus root 2 over 2. Okay. Well, what does that mean? I think I did something wrong. Okay, so I put too many fraction bars. Okay, so I'm putting 2 plus root 2 over 2 down here. But now 1 over something means reciprocal. So that means I flip this one. So this is the same as root 2 over 2 times 2 over 2 plus root 2. And that is the same as root 2 over 2 plus root 2. Unfortunately, I can't have a radical in the denominator, so I'm going to use my special difference of squares trick. Of course, it's not my special trick. I wish it were my special trick. So this is going to make, I've run out of room. What should I do? I should shrink this page, shrink this page, measure this page, and make a new page, Okay. So now I'm going to copy this over here. Root 2 over 2 plus root 2 times 2 minus root 2, 2 minus root 2. You notice, of course, that this equals 1. So it's legal to multiply this fraction by this fraction because I'm just multiplying by 1. But why would I do that? I would do that so I could use difference of squares here. Notice this is a difference of squares. So I'm going to copy down the top. Let's copy it down. Right? And on the bottom, I get 4 minus 2. Why? Because this is a plus b times a minus b. And that equals a squared minus b squared. Squared, that's a, that's b squared, that's b squared. So I have rational or as a denominator. And now I can say that this is 2, and I can also distribute the numerator. Sorry, I'm doing this in a step-by-step way because when I do things in my head, I tend to mess up. So I can now factor out 2, and the answer is root 2 minus 1. I hope that is the correct answer. Let me know if it's not. Even if you understand how to do the problem, I would appreciate knowing if I messed it up. So thank you. I think that's all we needed. Is it? Yes, I believe that is all you needed. So, if there are any questions, please let me know. Thank you. Pleasure to work with you again, Erica. Yes, peace and love. Bye.